record. So thank you all for joining tonight. I really appreciate your attendance. We're honored to have Dr. Amber Wise joining us tonight. She's the Scientific Director of Medicine Creek Analytics in Washington State and the Programming Chair for the Cannabis Chemistry Subdivision at the American Chemical Society. She's going to be addressing variability in testing results, how to properly interpret a certificate of analysis, and the hot topic of synthetic cannabinoid products. So feel free to write any questions that you have in the chat as we go. We might even break up the conversation with questions every once in a while here just to keep things flowing. And we'll also have some dedicated time for questions at the end. So without further ado, I'd like to hand it over to our guest, Dr. Amber Wise.
All right. Well, thanks very much for having me. And it's good to be here. Good to see everybody. I have a lot of material to go over. Like I said, I was just finishing up slides. And so I kind of broke it up. There's like a shorter intro part. Let me get started here before I get going. So, all right. This picture at the top here is what Westerners call Mount Rainier and the native people of this region, which is outside of Seattle, Mount Tacoma. And it's very gorgeous. I took this photo out the window of our lab. So we're very lucky to live in such a beautiful place. We are tribally owned by the Puyallup Native American tribe, and we've been around. We're a third-party testing lab. I've been a manager for 4.5 years. And the lab has been open for over 6 years now. So we've been around for a long time, and ups and downs of the cannabis industry. And obviously every state is its own jewel unto itself, and we'll get into some of that as we talk. So let me see, is this moving forward? There we go. Really quickly on my background. So I am originally from Wisconsin. I have a bachelor's in chemistry. I went and got my PhD at UC Berkeley. I did a postdoc in San Francisco, and that was focused on risk assessment, toxicology, and everyday exposures to chemicals in the environment. I then became a chemistry professor for about 7 years, lecturing at a bunch of different places. In Bangladesh, I lived there for 1.5 years, San Francisco, and then I had a tenure track position in Chicago for 3 years. You know, what everybody wants as an academic, but got burned out at the end, long story short, and transitioned into the legal cannabis industry in 2016. And started out at an extraction company. Those pictures are of me at the first day, the first batch of distillate we got out of the wiped film distillation apparatus. That was my work partner, Merlin. She was great. And that's me with a flask of terpenes that we distilled there as well. And I've been, like I said, at the lab for over 4 years. And yeah, so the lab provides third-party testing services for, legal licensees in Washington State. Our deliverable is the COA that we're going to talk about later, the results, the certificate of analysis. We also do a lot of other testing for clients, special projects, R&D testing, research and development testing, troubleshooting as well, and then we've also published a couple of papers in 2021 in the peer-reviewed journal articles. And I have a slide on that at the end, but to summarize, if we have time, I can go over it, but we measured heavy metals in the vape aerosol from cannabis cartridges. So I'm just going to get right into it because like I said, I have a lot of material, but I'm definitely going to take questions as well. So I'm going to talk a little bit about some of these new cannabinoids we're seeing, semi-synthetics. There's a lot of terms people are throwing around, legal, natural, and then how to read a COA, how to interpret it. And I'm going to combine the COA or use that platform as a way to discuss some of the ins and outs of lab testing, some of the nuances that most people who don't work in an actual lab don't know. And while I credit shows like CSI for inspiring a lot of people to be in the science realm, I've had a lot of students over the years say like, oh, I became a chemist because I watch CSI and I love it. It is not very true to science and what it's like to actually work in a lab. So, a lot of people think it's really easy, and it's not at all. And then, like I said, time for discussion. So I have this alphabet soup image up here to talk about some of these new and synthetic cannabinoids. So I know there's a lot of molecules here, but there's not going to be a lot in this talk. And this is really just to do some comparisons. As I'm sure you all know, you're high level students here. This is a master's program, right? Yeah. That all of the cannabinoids come from the same. Can you guys see my arrow? Let's see.
Yes,
There
we
we go.
can.
There we go. Okay. All the cannabinoids are synthesized from one parent cannabinoid, CBGA, right? That's all the same molecule here on the left-hand side. And it's a different enzyme that actually does the conversion into the three main classes of natural cannabinoids. So you do actually need to have genetics, and those enzymes need to be turned on and functioning for these molecules to even exist in the plant material. And then right, we have these three different classes of molecules. The plant, as you know, makes the acidic form, and then we can decarboxylate them. We lose a carbon dioxide, and we get the neutral form of these molecules. These are just a handful of other molecules that you may have heard of. The 11-hydroxy, and so the green arrows are sort of one step away or one version away from THC. And the red circle is sort of how it differs from THC. So here on the 11-hydroxy is what your body makes once it goes through your liver. It just has an extra hydroxyl group there on the top of the ring. THCV, the varins mean they have a variable length of this chain. So here, this aliphatic chain is shorter than it is in regular delta-9 THC. CBN is a degradation product of THC. The only difference is it has a couple fewer hydrogens, which means it has 2 more double bonds in this ring here. And delta-8 THC, which we'll talk a little bit more about in a minute. The only difference there is the position of this double bond between the 8 carbon and the 9 carbon on delta-9. So almost exactly the same molecule. And if you're not paying attention, right, in an organic chemistry class or in a marketing pamphlet, you know, it's very easy to choose the incorrect molecule to draw. And then, of course, we have CBD, and I have a green arrow here between THC and CBD. They actually have the same molecular weight. And it's a little bit difficult if you're not paying super close attention. This ring is not actually a ring in the CBD molecule, it's open. So there's only 2 ring structures in CBD, but there's 3 closed ring structures in THC. But they have the same molecular weight. So that's another reason why you can't really separate the two through distillation methods, is because they are so similar. But we obviously know that they have very different behavior in our bodies. So even that very subtle difference there of an open ring or a closed ring causes very large implications in 3-dimensional space in terms of the shape of the molecule and how our body takes them up. So these are all, except for delta-8, really more or less naturally occurring. We can get CBN degrading from plant material over time, usually not in very high amounts. You can also convert into CBN quite easily, some extract. And then delta-8, you know, you can argue that yes, the plant does make over 100 different cannabinoids, but these types of molecules are rarely ever seen in any large amount. So in my opinion, delta-8 is not really considered a naturally derived cannabinoid, because when people are having large amounts of delta-8, they're not extracting them from the plant material themselves, they're converting it. So what are these sort of new cannabinoids? I had that alphabet soup picture up earlier. There's a lot of different terms people can use for them. Semi-synthetic, converted cannabinoids, naturally derived, federally compliant, CBD derived, you know, like all of these different terms you can see in marketing. And some examples of them might be delta-8, delta-10, delta-7, delta-6, delta A and B, all versions of THC, right? And again, those are really just the chemistry way of describing where the double bond is located. THCO acetate or THCO, HHC, hexa-THC, THCP. I mean, I could go on, and I'm sure there's going to be more in the future. But you know, you've probably been studying cannabinoids for long enough now to have heard of the main ones that you're going to encounter in naturally derived products. And so almost any other, you know, cannabinoid that you hear of is, you know, potentially not actually, you know, naturally derived. We are often seeing these products a lot in unregulated states. I'm from Wisconsin. I was back there this summer. They have no legal cannabis at all, medical or otherwise. And there's a Delta 8 shop on every corner. So like, how did we get here, right? I mean, the cannabis plant is really good at making cannabinoids, and we know that they have a lot of useful applications. So why are we seeing like all of these things pop up? And you're probably aware of this, but some people aren't really necessarily. It wasn't that people are necessarily trying to get high in new ways. It really came down to having way too much CBD on the market after USDA Farm Bill sort of legalized the ability for people to grow hemp, which is, you know, less than 0.3% THC in the plant material. And so there just was a ton of CBD on the market, and we had a huge oversupply. Chemists can make almost any molecule you want. Sometimes it's more expensive than others, right? So chemists are like, well, we can help you out. You got too much CBD, we'll change it into something else. And lawyers can sort of argue that, hey, we're going to say this is legal because these molecules aren't specifically listed on the DEA schedule, or you know, they're not listed, or they're not explicitly called out, or it's not the same thing as Delta 9 THC and all of these things. But we do know that many of these molecules, if not all of them, have psychotropic properties, can alter, you know, your psyche in some way. Some of them, you know, we know about. Some of them we're able to quantify. And I just wanted to mention one really quick thing about Delta 8 flower. There's a lot of confusion. And I feel like since I work in the industry, I forget a lot that people don't really understand. And so this is literally just a screenshot from me Googling Delta 8 flower. And if I was you know, any random person, I would just sort of automatically assume that this was a naturally occurring thing. But when you see Delta 8 flower, what's happening is like one of two things, most likely. People extract CBD from hemp. They have a high CBD extract. They do some chemistry on that CBD. They convert it to Delta 8, and then they take that liquid and spray it back on some flower material. Or they might, you know, dip it, or, you know, some other treatment in some way. So this is generally hemp, CBD flower, and then some other mixture of Delta 8 and who knows what else sprayed on it. And sometimes you can tell if you look at it that it just doesn't look quite right. Sometimes you can't tell at all, right? These pictures, at least from the internet, to me look like anything I'd buy in a legal store here. So this is something I've, you know, had to describe and explain to a lot of, you know, old hippie friends of my parents who are buying this stuff in stores and gas stations. And so, you know, why are people doing this? Well, first of all, the chemistry is really easy and it's available. It's out there. These are 2 papers that are freely available online. They're in peer-reviewed journal articles. And I'm not even going to, you know, reference all of the online forums and, you know, that sort of thing that kids these days can get off the internet, right? And so you can, you know, convert CBD into a number of different molecules in 1 or 2 steps, using a number of different chemicals. Some of them I'm a little terrified of. Some of them I don't really even know what they are. And so there's so many issues with this. These reactions, right? This picture here makes us want to think like, oh, we just like take CBD and we get a pure version of whatever this is. Delta 11, it says Delta 10 over here. But these reactions are never 100% pure. You always get some other side reaction. You don't get full conversion. You get who knows what coming out the other end. And a lot of times a very small difference in the reaction conditions, like it got a little too hot, or you ran it a little too long, or there's a little too much oxygen in there, can drastically change what product you get out the other end. Which sort of leads me to my next step, is that a lot of people that are making these, you know, in large scale are often not very well trained people. They don't necessarily understand the chemistry of what they're doing. So for me, it's a worker safety issue. Like I said, you know, a lot of people get these instructions online and order the materials and just start following the instructions, right? And they've never had a chemistry class. They don't know the safety of handling these chemicals. They're often at very large scale. And when I said CSI wasn't like real life, Breaking Bad was actually very close to the real chemistry. And you see all that like safety gear that they wore in that show, that's how much safety gear you should be wearing when you're dealing with gallons of toxic materials, which often is happening in these situations. Another issue is that analytical labs can't really identify what they are. So this is a spectra, and I'll talk a little bit more about what these look like later, but essentially this is from a testing lab. These two peaks here, we know what they are because we have standards for them. And all these other peaks here, they don't know what they are. Oh, let me get this light going on. This is oops. Sorry, I have a light issue. So let me just get this turned on here. Well, you don't need to see me. You can see my slides. It's motion sensor and I can't get it turned back on. Okay, so we don't even know what these side products are. We know that these reactions are not necessarily forming what they think they are. So this is a spectra of what somebody thought they were making was delta 10. Well, there might be some delta 10 in there, it might be one of these peaks, but I don't know which one it is, and it's certainly not pure, right? There's a lot of different molecules in this mixture. The analytical labs also don't test for the reagents and the chemicals that are used to make these products, like all the acidic solvents and all the intermediate like catalysts and things that you want to use to get these reactions to go. So we don't know, and we don't know like how well the processor is cleaning these products up, and we don't have any way to test for how many chemicals might be left behind. These are not standard chemicals that labs test for. And then there's also, because of all these issues, there's no guarantee that even if there is a label with a number value on it, that it's true at all. So it's an enforcement issue, and it's a public health and safety issue. So these are my, a lot of my opinions on these, and I've raised, some general issues on a lot of these molecules. The other thing that I didn't mention here, I don't think, is that we also don't have really any safety data on these molecules being in humans, right? We have a little bit of safety data from the 70s and 80s on Delta 8, honestly, in animal models, and I think there might have even been some human studies done as well. But all these other ones, the hexahydra THC, the THCO acetate, we don't know what the safety profile is of these at all. So, in my opinion, I think we could spend a lot more time focusing on all of the myriad molecules that the cannabis plant already makes and is very good at making, and understanding their role in medical applications and in all of these other things that cannabis can do. And I do also want to say, like, there are reasons why we might want to modify molecules, right? Many, many very good drugs are slight modifications of something that we already know. So I don't necessarily want to say like changing a molecule a little bit is always bad, but there are safety testing protocols and proper channels to go through when you make a new molecule before you release them into the gas stations of Wisconsin, right? And I'm just using that as an example because I'm from there and I've seen it, but they're in all kinds of states all over the place. And it's also, in my opinion, one of the best arguments for having a legal regulated market that has safety standards attached to it. We don't have an issue. I mean, you can buy Delta 8 in Washington State, but it is nowhere near like it is in states that are illegal, because we have a regulated program. People want to access cannabis for whatever reason. They can. If they're children, it's very difficult, right? All of these like safety protocols are in place. And, when there's gas stations that advertise Delta 8 on the A-frame outside the front door, there are enforcement people that have, there's rules in place where, can be enforcement actions taken. But all of these states that just say, THC is illegal, they don't really have a leg to stand on for all of these companies. So it's a really sticky issue. And that's where I was going to stop for questions on this topic before I go on to talking about COAs. Anybody? I see there's one chat. Questions so far? I'm happy to move on. There's a lot more in the rest of the talk, so this is the short part. All right. I'm happy to come back to this topic at the end as well. So, okay. COAs and some ins and outs of lab testing. Like I said, lab testing is a lot more complicated than people think it is. We don't just like throw some bud in the machine and get a nice printout out the other end. I have this table over here, I'm not going to go over it, but each color is a different test, and each line is a different method you can run that test. So you can see that we have to have at least 1, 2, 3, 4, 5, 6 different testing platforms to just run a standard compliance panel for cannabis. And so the general process, and there's some exceptions for sure, is first we have to sublot what we receive in the lab, right? We have to weigh a very tiny amount out. Cannabis oil, if you've never actually handled it, extract is like the stickiest material on known to man. And so it's very difficult to weigh out a very small amount accurately, just in case you've never done it. And then we have to do some chemistry. We have to extract the compounds that we're trying to test for. And it's easy to extract cannabinoids because there's a lot of them there, right? It's like 20% of the flower, maybe even 80% of a distillate, right? There's lots and lots of molecules there. But when we're talking about extracting pesticides and leaving behind all the stuff we don't want to look at, gets a lot more complicated because hopefully there's very, very tiny amounts of pesticides or hopefully none at all, right? So the extraction phase has to happen and there's some chemistry there. Here's down in the lower left here, some pictures of actual vials where we did some extraction phases, and there's, they're liquid and they're different colors because this is flower and this is darker concentrate and this is distillate. And then we have to filter and transfer these into these smaller injection vials and dilute. And then we have to put these injection vials in the machine. We have to inject them, run the samples, software has to analyze it. We have to, make sure that everything's correct, check our quality control injections, and then quantify the results, and then, formulate a result file, right, a COA. I did want to just do a really quick overview on how we quantitate things. And this is basically referring to cannabinoids, terpenes, residual solvents, pesticides, metals, all of these are more or less the same. This diagram here is for cannabinoids. And so the first thing you have to do is buy the pure standards from a company for the molecules that you want to test for. So we have a standard list of 11 cannabinoids. Some labs have more, some have less. So this should be 11 peaks here. And first thing we do is we make up known concentrations from low, medium, high, and we inject each one of those into the machine. That's what you're seeing all these different colors here. So the green one is 100 ppm concentration, and it goes down to 2 ppm concentration is the smallest one. And what we do is the area under that peak, the two-dimensional space under that peak, that is basically the signal that that molecule is giving. So if you have more molecules, you have larger area under that peak. So then we create a calibration curve. So we plot that concentration of the known standard, right? So here we have the 2 ppm, and we have 5 and 10 and 25, all the way up to 100. Those are the red dots. And this is the area under the curve that the instrument is just plotting. And then we get a nice, remember I don't know what class you learned this in, basic calculus, y equals mx plus b, right? And then you make up, so you run your calibration curve, you hope it's nice and straight. If it's not, you have to redo it. Then we make up our samples, the unknowns, right? Our flower samples, our concentrate samples, we have to dilute them to make sure that the injection concentration falls within this calibration range. And then we find, oh, okay, so the area under the curve for the unknown falls right around here. Well, that means it's 35 ppm, right? That's what and the instrument kind of does that analysis for us. But again, we can only identify or quantify the peaks that we have standards for. So this is that same spectra from before where we didn't know what those peaks were. We can't quantify what these peaks are. We can only, because we don't have a standard to compare it to. This is a delta 9 peak and this is a delta 8 peak. And the reason we know that is because we bought standards and they come out at the same retention time. So it's not, there are ways to identify molecules that are unknown. Cannabis testing labs don't really have those methods, and they're very time consuming and they're complicated and they're expensive. So it's not that chemists don't have the ability to identify these molecules. It's just very hard, and the industry has a difficulty accessing those resources. So just a brief overview about how do we quantify things and assign number values to them in terms of the COA. All right, so then who can make a COA? Well, this varies state to state. I have this little sort of rainbow. The colors mean nothing here. This is just means that like every state that has a legal cannabis program has different accreditation requirements. So essentially, there's two kind of different types of accreditation requirements. Some states require that like somebody in the state, maybe the Department of Ecology or the Department of Health or the Department of Agriculture, will come in and look at your facility and look at your methods and say, yeah, you guys know what you're doing. We're either going to give you a license, or in Washington state, the labs aren't actually licensed. We are accredited, sort of different legally. Or some states just require the lab to be ISO accredited. And what that means is a third party comes in. And so I have these three examples of companies that will do ISO accreditation. And there's probably others as well. These are just like three big ones. And the bottom two for sure do a lot of cannabis lab accreditations. So this is A2LA, PGLA, ANSI. We pay them, they come into our lab, they look at all our methods, they take literally days while they're on site and looking in every detail of every bit of data we have, and then saying, yeah, you're doing a good job, or you need to improve in these areas, right? Some states require two levels, right? Like the state has to license you and you have to have ISO accreditation. Washington state doesn't require ISO accreditation, but they do require some sort of state approval. Some states don't require anything. Like any lab can just open and do whatever they want. So there's a whole range of who might be generating these COAs to begin with. This is one of the hardest parts about putting this presentation together, is I can't make it specific because I know all of you are different locations and every state has different requirements. So I'm giving out a whole bunch of different examples, and I'm sure you'll view, even within the state, the COA, the format, the layout looks different lab to lab. So if you're confused if you ever looked at one of these documents and been confused, that does not mean that you're not a smart person. Okay, so just some fundamental definitions. COAs exist for all kinds of products in all different industries. It's not specific to cannabis, but cannabis is actually very highly tested compared to other industries. So I have a friend who likes to say that cannabis is safer than salad, because we hear every year that there's recalls for salad for E. coli getting people sick, because not every single batch of salad is tested, right? They do spot checks here or there. They check the facility once a year. But, in a lot of places, every batch of cannabis is theoretically tested for microbial. So it's, potentially much, much safer than your salad or your peanut butter. And generally they're required for legal sale. Again, the requirements vary state to state. There are often two different kinds of COAs. We have one that we label compliance, and that's for legal sale, right? This is test results that are publicly available to people who buy this product. We report those results to the state of Washington, or what we call R&D testing. Some people call it other stuff. And that's just between the client and us, right? They want to screen something for pesticides before they extract it, or they want to see what their cannabinoid numbers are before they harvest. And so then we just send the results to them, and that's all we do, and they pay us for our services. The availability of these COAs can vary, and also where you access them. There's a lot of CBD companies that sell online that have their COAs available. Many of them don't. Sometimes there's a QR code on the label of a product that will lead you to a COA. Some states require that. That's a great idea, in my opinion. Washington does not. Some labels have a summary of the results. They might just list the THC values or something else. Some states require them to be available at the retailer or require them to be available online. Some states don't. So again, it's consumers don't all have equal access to these, even in regulated markets. Okay, so I'm going to go over a few different parts and things that we should be looking for. And again, all of these images I sort of want to say, because this is being recorded, these are all images I just clipped from the internet on COAs that were, available either for products, lab websites that were explaining how to read COAs, examples of good and bad COAs. So I don't have image credits for all of these, and sometimes it's pretty obvious, but all of this was just like Googleable in terms of where I got the images. So some things that should definitely be on a COA, and if they're not, there's a bunch of red flags for me. The company that it's getting tested for. So I kind of have these color coded here, the red. So you can kind of see I have 3 different COA examples. They're located in all different places, right? So the red ones are all the company names. The yellow ones are the product name. The green squares are some identifier number, either a state lot number, metric number, some sort of thing like that. And you'll see a couple of these COAs don't have them. That's sometimes okay. But certainly if, you're trying to buy some CBD online, or you bought some product and they say their COA is available, there should be a lot number on the package and it should match the lot number that's on the COA, right? Otherwise, it's probably not the same test. The matrix or the product type, you want that to, if you bought a tincture, you don't want this to say flower or something like that, right? That should also match what kind of product it was. And the lab should be identified on the document as well. Usually there's some contact information, at least where the lab is located. So we've had people call and ask, like, hey, I have this test or this results file. Can you tell me if it's real or not? Because there's a lot of examples of people faking test results too. So, there are some safety guidelines in place to prevent that. So you can always call the lab or reach out and ask, if you have a document, they should be able to, if you have the actual document and the document number, they should be able to say like, yes, this is real or not. There should be a signature somewhere, either the top or the bottom from a lab staff, and a date of when that report was generated, and it should hopefully be relatively recently. So these are all pretty fundamental things that should be on all of them. But again, where they are located is totally up to the lab, really. Some other things you might see, you might not. There's no standard layout. Some states require certain things to be on there, some don't. Right, there's a lot of summaries. Some people who aren't necessarily very science oriented, they want to see something like this. Everything passed, everything's green, everything's great, right? And there's no numbers down here, but there's numbers probably somewhere else in the report, but this is like right on the front page and it just says, okay, everything's passed, I can move forward with this. You'll notice here, this one sort of says pathogenic microbial not tested, right? Maybe what wasn't required for this type of product. Sometimes there'll be pictures, right? And summary graphs. This is like a terpene profile of the top terpenes they tested, maybe a summary of the cannabinoids. Could be any sort of thing. Number, units, percentages. We'll talk about units in a minute. So again, could be a whole bunch of other things on here. And most of this is like customer service related in terms of like ease of the customer understanding what's on the report, little tweaks that the lab thinks their clients want. Some other things that are generally there, and if they're not there, it raises red flags for me, but they don't always have to be there. If they're missing, it doesn't necessarily mean it's like terrible. A QR code. So there's a couple reasons why there might be QR codes. One is the lab, once the lab makes the results, we give the QR code to the client for that file, and they can use that on their website to send to stores as part of their marketing. They can put it on the label so the client can just look up the results if they want, right? There's a whole number of ways QR codes get used. So that's like partly for the client. And then it's also a way to confirm that the document is real. So you should be able to, if there's a QR code on the document, you should be able to, look at it and it should be the exact same document. Obviously you can fake a QR code to lead to a fake document, but it is one extra level. Like I have seen someone fake a result of ours and the QR code went to the original. So you can just see like the fake document with different numbers than, where the QR code leads them. So anyway, it's another level of confirmation that, it's a quality test result. Generally, there's some accreditation information. So here, these are 2 different lab results. This is from our lab. the accrediting body, and then the accreditation number. So our lab number is 91428. This lab number is 80585. I don't necessarily have to have the logo, but if they're accredited, that number will generally be there. Often there's disclaimer statements. Those vary. Generally, there should be some acronym definitions, right? There's a lot of units and acronyms that get used on reports. And if I don't see them defined, I usually -1 star in my head. And often there's photos as well. And so these were just a couple examples that I wanted to point out a couple things, right? Here's some accreditation information down at the bottom, and their accreditation number is there. It's very tiny. This doesn't have the accreditation logo, but they do have their accreditation number listed down here. And so you should be able to go to the accreditation website and look up that number. That's publicly available information, and just confirm that they are, in fact, they have been inspected by that accreditation body. They didn't just make up that 5-digit number and throw it on here. And there's some things on this that sort of was a red flag for me. There's some weird formatting and letters in here, and this might have just been the way it got downloaded. And there was a couple other things on here that I wasn't sure about. But again, you can see there's like summary diagrams and things in here. This one wasn't signed actually. So that means, could be a number of things. But I don't ever let results be released to the public without, a signature on there. So this could be an example, for instance, right? There's not a lot of other information at the top here about when it was received or analyzed. So this is probably just like an example layout, for how the data would be displayed. Okay, a few more things about language and data in the COAs. Potency is the wrong word. You guys are learning about medical applications, and potency means a very specific thing, right? With absorption and distribution and metabolism and excretion. And we can't just apply that across the board with all the different ways that cannabis is made and ingested and used. So really, when we talk about potency, we should be using terms like total cannabinoids or cannabinoid profile. Because as we know, right, if you smoke a joint that has 200 milligrams total of THC in there, you're not going to inhale 200 milligrams, right? First of all, it's THCA. It has to be converted to THC. That's not always 100%. And then half of it or more goes up in smoke, literally, while you're standing around not inhaling. Vaporizer cartridges, obviously, different concentrations, different mode of inhalation and aerosol. Edibles, right? If you say you take 10 milligrams of edibles, well, first it has to go through your stomach and then your liver, and then you got to get converted to 11-hydroxy. And how much of that 10 milligrams actually got converted to 11-hydroxy? How much of it actually makes it into your brain, right? So potency is not really a great term. So I try to be careful in my language as a scientist and use terms like cannabinoid profile and things like that. And then, of course, potency, I'm hoping that you are all recognizing at this point that higher potency does not necessarily mean you will get more high, right? In terms of just smoking flower or inhaling cartridges. This is a very recent paper. Ethan Russo's an author, and a number of other great scientists that showed people inhaling different concentrations of THC and different terpene profiles, and the aroma of the terpene profile that they liked gave them a better experience. It had nothing to do with the levels of THC. And the terpene profiles that they didn't like as much, they did not have quite as good of an experience. So again, the number value does not necessarily correlate to the user experience at all. And I don't have time to go into the entourage effect here, but hopefully you've learned about some of that already in your class. Some notes on math and units. I deal with different units all the time. I taught undergrad chemistry, so I'm pretty comfortable with units, but a lot of people I realize don't feel comfortable with math. And, there's all kinds of units that get used in cannabis. So I just wanted to throw out a few things, right? If we have a beverage and there's 10 milligrams of cannabinoids in that can, That's a number that we, generally understand. But if you convert that to weight percent, we're talking 0.003%. That sounds super low, right? In fact, if some states say that the 0.3% cutoff for THC applies to all products, that this would be a completely legal product and you can buy 10 milligrams of THC in a store. There are states that have that. And another example is some states allow there to be more than 10 milligrams in a container. This is 100 milligram in the whole bottle, but it's only 0.03% by weight, right? Because most of the weight of that product is water. This is, little gummies. They each have 10 milligrams in them. They're much smaller than a can of soda, right? There's 80 milligrams in these 8 little gummies here. Those will probably, if somebody ate all of those, would probably be very high, right? Of course, there's spectrum of reactions to different levels. Some people, 80 milligrams is not enough for them either. So again, these are always guidelines in terms of what a single serving is or what a dose is. So I don't want to spend too much time on there, but pay attention to the units is what I'm trying to say. And don't just see a number and assume it's part per million or assume it's percent or, assume it's a dose, right? Those units mean something and the usage of units is not standard, unfortunately. Another fun thing is, as we know, there's often more than just THC or CBD in products, and there's a lot of loosey-goosey labeling rules. And so, some producers will just put the total THC number on the front, and they just add up all the cannabinoids, and they'll put a total on the front with a number. What does that really mean? Are we talking total THC? Are we talking total cannabinoids? Are we talking, how do we do this? And so 2 examples I just came up with is this one down here on the bottom. This is some half decarbed flour, actually. And so there's some CBGA and there's some THCA, and some of it's been converted to Delta 9. So some people might actually add all of these up and put a sticker on the front that said 18.6%. The total THC is generally some slightly complicated math equation where you have to take the amount of THCA, multiply it by 0.877, and then add that number to the amount of THC present. So in this case, the amount of total THC that you could potentially ingest if you had all of this product was 16.9%. So where does this 0.877 come? I didn't have time to put in the molecules here, but the molecules weigh different amounts. And so when you lose that CO2 molecule, the weight percentage changes. And it's 13% difference. And that is this 0.87 or 0.13% difference in molecular weight. This example here, if you added all of the cannabinoids together, you might put a sticker on the front that says 83%, right? Is that the number? I have a box over here. Oops. But actually the total THC is 75. So there can be some fun math on labels, and sometimes it's not even clear what they're talking about. I'll just see a label that says total and a number. Is that THC? Is that THCA? Is that all of them? Right? So you don't even necessarily know if you see a package, like what we're talking about. Another thing I realized varies state to state is dry weight correction. So contrary to what some people understand, good quality flour to smoke actually has some moisture in it. Too dry flour is gross, it's harsh, it doesn't have good flavor. And it's a range that some people that people think is generally good, and it's again approximately 7 to 13% water weight. However, so the example I have here is if you send in a sample of 1 gram of flour and has 10% moisture in it, and we tested at 18% THC, that's 180 milligrams total in that little bud, right, of THCA. But if we dried that out completely, same bud, now it weighs 0.9 grams, theoretically, 10% less. Now we still have 180 milligrams of THC in there. And now the number should be 20%, right? So we can do this math literally, right? We can actually just dry the plant material out and then test it when it's ultra dry, or we can kind of do it mathematically in the lab, right? A moisture test is often required, and we can just do this conversion mathematically. This varies widely state by state and lab to lab. So in Washington state, we are not allowed to dry weight correct. We cannot dry the plant material before we test it, and we're not allowed to mathematically change the value. We have to test as received. Some states require dry weight correction. So, and some states actually dictate a mathematical equation that you have to use. So again, you know, we have in Washington, the grower can pick their own sample and send it to the lab. I know I've had growers tell me like, oh, we dry the shit out of the flower that we send to you, so we get that extra couple percentage points at the end, right? To bump those numbers up higher. So it's games people play more in the industry again. And what I'm trying to say by this dry weight correction, it's not necessarily bad. It's mathematically true. It's just difficult to compare lab to lab, state to state, sample to sample, right? When you don't necessarily know if they're doing this correction or not. Just a statement I'm going to put out here. 30% cannabinoids total is pretty much the maximum the flower can make. Anything higher than that isn't really real. There's a huge problem with lab shopping right now. I was in California a few weeks ago, looking at flower on the shelf. The smallest number I saw was 28%. Most everything was above 35%, 38, 39%. That's just not real, folks. And you can argue with me all day you want, but fundamentally, there's a plant that structurally holds itself up. This is my botany slide. I'm sure you know by now that the cannabinoids and the terpenes are made in the trichome cells, right? There can be a lot of trichomes on a bud. That's where they generally reside. However, the cannabinoids and terpenes are, you know, a small fraction of that trichome actually. And the trichome is also not 100% of the plant. There's a ton of cellulose in that plant that's holding the bud material together, right? Structurally. There's photosynthetic molecules, there's fats and lipids. Every single cell in this bud is surrounded by lipids, phospholipids. That's just fundamental biology. And so you can't actually really have 40% cannabinoids in a bud material. Just mathematically, it's not going to work out. So there's a number of ways that labs can push those numbers up. I don't have time to go into all of them here. Some of them are intentional, some of them are not intentional. But I did have one, I guess I don't have the slide right here in the right place, but so I just wanted to sort of put that out there. And you know, when you see really high numbers like that, you basically shouldn't believe them. And in my professional opinion, most of the really high quality flower out there is between 12 and 25% max. There's some outliers, but you know, the grow facility I used to work for had this strain that would never really grow anything more than 12, 13% cannabinoids. And we could never sell it at the stores because they wanted higher percentages at the store. And the staff would like fight over the harvest of that plant because it was everybody's favorite. Everybody got really high. It was really fun. So it clearly wasn't the THC levels. It was something else to do with the terpenes or other molecules in the plant. And so anyway, I just want to put that out there. There's a lot of conversation about that right now. And I do have another slide about that if we have time. So another set of information that you'll see on the COA are a bunch of acronyms. First of all, 0 is not a number in analytical chemistry. So this squiggly line here is potentially a blank sample that you inject in your machine, and this is the actual signal that you get. So is this a signal here? Is this something that's there? Is it noise? It's hard to say, right? So my point is, we can't really ever say that there's 0 molecules present. What we can do as an analytical lab is we can say, this is the concentration where we know we can see things down to. And this is the concentration where we can actually quantify that number with confidence and assign a value to it. So I made a little diagram here in the bottom of LOD means the limit of detection. So that's really like what the instrument can actually see. Anything that the instrument might assign below this value is noise, essentially. And then we have this LOQ, which is a limit of quantitation. And so anything above that, we should be able to assign a number value. And on this number line here, I jump from like 0.3 ppm all the way up to 100. You can have an upper limit of quantitation, and what that means is, you know, that calibration curve line, if you have your upper standard at 100 ppm, if the machine measures something that's like 200 ppm, you actually have to dilute it and re-inject it so it's within that range. So what you see on test results is if the number is below the LOD, you'll see a non-detect ND, or potentially something that's less than LOD, right? And then there's always this sort of window between the LOD and LOQ. And what is that zone called? In our lab, we write DET, meaning detect. So that means like, yeah, we can see it and we can identify that molecule, but we can't really assign a number to it. So it's trace levels, right? Some people will put trace on the results. Some people will just put less than the LOQ. But once you have a number that's above the LOQ, then you'll report that number, you know, on the result or on the test. Okay. Oh, right. And the LOD and LOQ will also depend on the matrix, the dilution factor, the injection volume in the machine. So the LOD that you see on the test result might be the instrument LOD. It might be the LOD that's associated with that matrix, like a flour or a concentrate. So for instance, we have LOD and LOQs for 3 or 4 major categories of cannabinoids, but otherwise we report the instrument LOD. It gets very complicated as to what that number is for any given sample. All right, so here's just some examples of COAs that have cannabinoid results. So this first picture is from our lab, right? We list the cannabinoids. We have our LOD and LOQ listed for each compound. These actually vary somewhat, but we chose the highest value for all of them and left them all the same number. The percent, this is the actual result in weight percent, and this is the result in different units, milligrams per gram. Sometimes that's the way people want their results reported. Here's another example of cannabinoid results, right? Here they have just the LOQ listed. They have the result in milligrams, and then they have the result in milligram per gram. So this is an example of like an edible potentially. It has a unit weight, and it says the total milligrams is 14.44 milligrams of CBD. And then, you know, they don't even have weight percent anywhere here, but they do have the weight percent here in some weird bar graph. Here's another example. They don't even have their LOD or LOQ listed. They just have the molecule. They have the dry weight percent, and they have the dry weight milligram per gram. So apparently this lab either dried it out or they did a dry weight correction, and that's fine. They at least told us that they did that correction, right? And they have some other graph where it's, you know, 83% of this was THC, and then they have some other molecules present, CBG, CBDVA, CBN, CBC, and I assume those are the other pie colors there. So again, you can see all the different ways that these are listed out. And this doesn't say our report might say non-detect here, and their report says less than LOQ, right? Both of those are scientifically relevant. Here's my slide about lab shopping. There's a recent, I mean, if you Google this, you'll see many, many headlines about lab shopping and potency inflation at labs and what's going on. This is a recent paper from 2021, and they looked at data, large amounts of data in different states. This is Nevada. So this is should be a smooth bell curve, right? Gaussian distribution. This is the percentage of THC. So a few samples test low for THC. Most of the samples test around 20%. Few samples test higher than that, right? But there's this magic jump right around 20. And that's really just the growers demanding that they can't sell anything below 20. The retail stores supposedly demanding that consumers won't buy anything that's less than 20. So this graph is from Nevada data. We don't see it quite as much in Washington, which I like to see, but you can see there it's not smooth, right? There is a jump there. Another interesting thing here is we have way fewer samples above 30% here in Washington state than in Nevada. And this is not just a Nevada issue. This is every single state that has lab testing. So I just have this figure from this paper because it was easy. But I don't want to dwell on this, but there's every incentive for clients to use labs that inflate potency, or maybe don't ever fail people for microbial tests, or don't ever fail people for pesticide tests. There's every incentive for growers and processors to use these labs, and there's every incentive for labs to cheat. So it's really hard for labs that are trying to maintain a lot of scientific integrity. And my lab is one of them right now. So I'm cautiously optimistic that, integrity will win out at the end of the day. All right, I want to leave some time for questions. So I'm going to jump to, I'm going to say one thing about terpene testing. A lot of people don't know this, but there's two very different ways to inject the sample, prep and inject the sample. Liquid injection method and headspace injection. And the liquid injection is you extract the sample, capture all the terpenes in a liquid and inject it kind of like you would for a cannabinoid test. The headspace injection is you actually warm the sample up, the terpenes evaporate, and you inject the gas phase, gaseous molecules of terpenes. And that's similar to residual solvent testing. There's pros and cons to both of these. The liquid injection, we can't see quite as low a concentration, but we do get more correct ratios of the lighter and heavier terpenes. And the headspace injection, you can see smaller values, lower concentrations, but it's, the lighter terpenes are more likely to evaporate than the heavier terpenes. And so you often don't get the correct ratios that are present. So again, good labs and good COAs will say if it was headspace or liquid injection. Both of them are perfectly appropriate and correct, but they just have slightly different variations behind the scenes. And again, you can present terpene data in a whole bunch of different ways. I have a lot of mixed feelings about Leafly, but they have this new-ish way of assigning terpene profiles. I won't spend time on. The other thing I just want to spend just a few minutes on before we finish up are pesticides. And this is a picture from my friend Julie Kowalski, and it's like looking for a needle in a haystack, right? It's pretty easy to see cannabinoids because there's a lot of them as part of the sample, or even terpenes. So like 2-3% by weight is a lot for an instrument to see. But pesticides, hopefully there's none there, or they're really, really, really tiny. And so how do we see that? It's a very different way of testing, and it adds a whole level of complicatedness to the testing that I don't have time to go into. The other issue with cannabis is every state is jewel unto itself, and all the lists of pesticides don't overlap. So this is an old graphic from 2019, just showing 4 states. And out of these 4 states, 5 pesticides occurred on all of their lists. A more recent paper from 2022 looked at 37 states that have regulated cannabis. 31 of those states require pesticide testing. There was no compound that appeared on every single state list, and only 4 compounds appeared on 27 of the state lists. So if you see a COA that says pass for pesticides, what does that even mean? And there's thousands of pesticides, and every state has a different list. There's a lot of issues with that. And this is a fun issue. Washington State has 2 different lists for medical cannabis and recreational cannabis. And they don't even have action limits listed for the medical cannabis. So what does that even mean in terms of passing? So I won't spend too much more time on that. I have some more slides on other types of testing, microbial testing, mycotoxin, heavy metals, some other things you might see on a C of A. Some states require you to report the uncertainty or the batch QC information as part of the results. Most states don't, but again, it varies. So, it's kind of a hot mess. And, is there any move towards harmonizing testing standards? Yes. This is actually the paper that I talked about that looked at 37 different states and all of their different testing standards. It's a really good summary of what's going on state by state currently. This was late 2022, it came out. But there are some groups that are trying to smooth some of these differences out, right? I mean, a lot of it depends on the state regulating bodies and the rules that they pass. But scientists are trying to work on making some of these things, the same state by state. So, a lot of people, we don't have this issue with like soil testing, for instance, in agriculture, because the EPA has standards. And if you want to test soil for agricultural products, you just look up an EPA standard, you follow their protocol, but those national level standards don't exist for cannabis. So there are some groups that I've listed here that are working towards, trying to get all the labs to do the same thing so we can actually compare COAs across state lines. And I didn't even go into all of the issues of natural variability of the plant material itself. And if, a bud from the top of the plant, a bud from the bottom of the plant can be 20 or 30% difference in number values. So, and they are both correct. And obviously, when you harvest a whole field and all of those different buds get mixed in together, there's an average value for each one of those pieces. And so that number value that's on the label means something, but you really have to take it with a lot of grain of salt. So I'm a little over time, but I'm happy to say as long as you have questions, you're welcome to email me any questions. I have my email address here. I often do a podcast, How to Launch an Industry, on cannabinoid and psychedelic science that is pretty high level in terms of scientific understanding. I think you guys might be a great group to listen to that. And we actually reviewed that testing standards paper on an episode last fall. I also, as Alex mentioned in the beginning, I'm a part of the American Chemical Society, and I organize all of the presentations at their national meetings. So if you are doing any cannabis research or master's thesis, or know somebody who's doing interesting work in the cannabis realm, please let me know. I'm now organizing for the meeting in August in San Francisco. And these are a couple organizations that are also working towards standards that I volunteer some of my time with. I also serve on a number of task forces, or have in Washington State, on cannabis policy. So trying to make sure that science is paid attention to when we make these rules and regulations as well in this new and exciting space that we are all navigating. So I will leave it there and take questions. Sorry for running a little over.
No, this was a fantastic presentation, Dr. Wise, and as usual, it was amazing to see you, summarize such complicated caveats within this industry into a concise presentation for us. So thank you.
I could give a presentation on almost every one of these slides individually. So.
Yeah, definitely. There's so much depth to all these topics. So I just want to give some time for some of the questions that we got submitted through the chat. So the first one from Alex Siegel is, what do you think about low potency D9 in gas stations and smoke shops? In the end, is it good that all the synthetics created an environment where cheap D9 hits the shelf, or is it just all unregulated garbage too?
I am a naive optimist in many ways, and I want to give people the benefit of the doubt that they're making quality products that are safe for their consumers. But I can't say that it's all garbage. I would never personally go into a gas station and buy something that was labeled Delta 8 or low potency Delta 9 or anything like that, just because I also don't ask for a COA every time I buy something in Washington, right? You just at some point kind of have to trust the process. But we are allowed to ask for COAs in Washington State at the store. They're supposed to supply them to us. If that happens is another story or not, but so the biggest issue for me with the synthetics is it's going to be really hard to put all of that toothpaste back in the tube, right? So say we get federal legalization and we have some sort of harmonized standards across the states, that's never happening. All of these molecules are already out there and people are making them, and they don't want to lose money on their business model, right? And so it's going to be hard to communicate to consumers that these are questionable products. There might very well be, the science could improve drastically in the next couple of years, and we could have great standards for some of these, and we could have decent safety screenings and have quality, clean Delta 8 product available. I'm not saying that that's like a terrible thing, but the way that they're being marketed and sold at this point is very worrisome for a number of reasons. Access to youth, right? I mean, in Washington State, we have like 98 to 100% compliance of IDing minors at the stores. So they're, minors are not getting cannabis from stores in Washington. But when they're being sold at gas stations, who knows? Next question.
Definitely. This one's from Sheridan. Is there a quantity of terpenes tested for that you think is ideal? Many states require different quantities of terpenes to be tested.
Um, I don't necessarily have a great, guideline. I think if uh I personally think that concentrates should probably be screened for terpenes. I think there's some companies that are adding too many terpenes, and I, for one, am sensitive to too many terpenes, and I don't even mess around with concentrates at all because there's just too many terpenes in it for me, and they make me sneezy. And some people have even more reaction than that. So in my opinion, I think concentrates should potentially be screened for terpenes. Um, Many states don't require terpene tests at all, right? It's just like an extra that some companies like to use for marketing. It's unclear if the consumer understands, right? There's definitely growing awareness and growing education about terpene profiles, but I think we're still pretty far away from understanding what might make you energetic or what might make you relaxed. I didn't even have time to go into any of that nonsense currently either. But to summarize, everybody's different and you can't really generalize.
100%. So many variables that go into that. Next question is from Jay Jin. Has there ever been a precedent for regulating compounds based on their theoretical chemical reaction, i.e. under heat? Both vitamin E acetate and THCO release ketene, which leads to pulmonary issues, electronic vape associated lung injury like symptoms.
Yeah. To the short answer to that question is not to my knowledge. And this is kind of getting a little bit to the last question of like, how many terpenes is too much, or what levels should be safe or allowed. Terpenes also degrade into problematic compounds. There's publications from Portland State that show that. And yeah, certainly the vitamin E acetate was pointed to as the E-Valley source. Again, that was a lot more in unregulated states than it was in regulated states. And another argument for having testing standards. And, however, our lab doesn't screen for vitamin E acetate. We have a test that we can screen for it, but it's not required. And we've screened a number of products right around E-Valley. People were really worried about it, and we never saw any in Washington. But we know from the CDC that there was definitely this in vape cartridges. So I don't think there's been any rules based on this, but we're potentially moving towards that slowly in various ways. But toxicology is very complicated. I did a lot of work in risk assessment and toxicology. I mean, cigarettes are legal, and we know that there's straight poison in that aerosol. So, just because it makes a problematic compound doesn't necessarily mean it will be regulated either. So anyway, I could talk about that for a long time as well.
Definitely. No, you bring up a great point. I get asked about vitamin E acetate all the time too, because it was so heavily in the media during the time, but it was kind of like a fad test. So it's really interesting to see how that happens even in science. We have these fads.
And it's not easy for us to just to get one of those tests going. I mean, it takes easily minimum a month or two, sometimes 6 to 8 months to get a test validated and worked out the kinks and all of that. Like you can't just order a standard and like run the test tomorrow. That's not, I wish that's how it worked.
Right. We have one more topic relevant question here from Sheridan. What is the percent variance on lab result that you would recommend? What's reasonable?
Well, it's another it depends question. It depends on the matrix. It depends on how it was prepped. Depends on how much was weighed out. It depends on how much it was diluted. So you can't even say that like 20% is like a good variance. So generally for natural products, 20 to 30% variance is a totally acceptable window. And so when you see 15% on a flower, well, what's the easier math? The easier math is if you see 20% on a flower, right, and 20% variance of that, so 20% of 20 is 4, right? And so it should be anywhere between 16 and 24% is still, in theory, like a correct number. Differences between labs, good luck. This is a conversation I have with clients weekly, and I'm tired of it. Because we don't even know if we're using the same methods, right? If we weigh out 5 grams of flour and dilute it with 100 mils, they weigh out 0.1 grams of flour and they dilute to 10 mils. The difference in percent uncertainty there is quite different. So they're still both correct. But you know, a lot of that is very complicated. And there's also different ways to calculate uncertainty. And some states dictate the equation that you need to use, and Washington doesn't require any uncertainty to be reported. So generally
More
for flour material, I say plus or minus 20% of the value. But it could be much less than that or much more than that, depending on the type of product.
Yeah. Another question I have for you from Michelle is if we can have access to a link to the webinar that you mentioned, which you can send to me at another time. So
What
I'll make
webinar
sure
did
to,
I mention? This webinar?
yeah, I'm not sure actually what webinar
Okay.
she's referring to. I thought I missed something, but
This one
if
is
she,
recorded and you are going to post it.
yes,
And
yeah, Michelle, if you're referring to this, this will be recorded and posted on our YouTube. There was one other question here. Victoria's asking some of the job titles that people have when working in a cannabis lab and their typical credentials.
oh, good question. I actually have a whole presentation on cannabis industry jobs for chemists. Or general scientists, right? We need more than just chemists in the cannabis industry. So the question was, what are some of the job titles that people have in lab? So our lab is very small, but generally there's some tiers, right? Most states require there to be like a science director that has either a PhD or a number of years of experience, like working in an analytical lab. And then there can be jobs like lab technician, and that can be anything from just someone who's never taken a science class, but they can print stickers, they can label, and they can sublot, they can weigh samples, right? You don't need a chemistry degree to like weigh samples out. And then you can be an analyst and run samples on the chromatography devices, analyze data. There can be quality control and QA review, where you look at everybody's batch data and results and sign off and say they're correct or not. You know, there's a number of different roles there. There can be chemical safety officer. Usually that's not full-time unless you have like a really, really big facility. Some other things that are relevant to testing labs are things like instrument technician. If you have a big lab with a lot of instruments, sometimes there's just one person in charge of like fixing them all the time and maintaining them. I wish I had one of those people on full time. And that's a job you can get. You can also work for an instrument company and travel to labs and fix things and do maintenance and things like that. And certainly there's all the other areas of science, right? Medical applications and policy and growing and agriculture and formulations, that sort of thing, making products for specific applications. There's so much science. I don't want to say I'm a little less optimistic than I was a couple of years ago in terms of the job opportunities. But I think that's just kind of the general economy across all industries currently, is everyone's a little bit iffy and somewhat of a downturn feel. But certainly there is a huge need for scientists in the cannabis space. And I, you know, enjoy the challenge myself. There's a lot of challenges, as I outlined here. It's like always something new and always something crazy making, but it's kind of, you know, I kind of thrive on variety, I guess, and I don't like too much repetitive things in my life. So I guess it's good for me and not so great for other people who like certainty.
Never a dull day is what I always say about
Never
this
know
industry.
who's on the phone, what rules are going to change, what's going to happen.
Definitely. Well, I think that is the end of our questions for tonight. Oh, we've got one more. Are cannabis labs accredited by CLIA and COLA or another body?
So CLIA is related to handling human samples like urine and blood. So drug testing labs that, you know, if you give a urine sample and you get a drug screen for your job, those are CLIA certified. And I don't remember what the acronym is there, sorry. It's like clinical lab something something. We do not have CLIA certification because we don't handle blood or urine. Thank goodness for me and my staff. So we are accredited by PGLA, which does the ISO accreditation. And ISO accreditation is for all kinds of analytical labs, soil testing, water testing, pharmaceutical labs, things like that, all fall under that same accreditation. So Washington State doesn't require that to operate, but we have that certification, and many states require ISO certification. It's a great start. It's not the be all and end all of being a good scientist, but it's a standard that we all have. And at the very least, it's the minimum that we can do.
Definitely. Well, I think that this has been very comprehensive, and all the other comments that we're getting in the chat are requesting a part 2 of your presentation or your involvement with faculty at UMB. So needless to say, it was very well received
Well,
and
thanks.
very appreciated by all the students that attended tonight. So thank you so much for your time, Dr. Wise. I
Yeah,
really
absolutely.
appreciate it. As you guys can see, you've got her contact information on this page here if you'd like to reach out for her for more information.
I'm
And
on LinkedIn too. It's pretty easy to find. So
she's such a cool lady to approach. She's been so amazing and supportive for me in my young career in cannabis science. So I encourage you all to reach out to her with any questions that you might have or any resources that you might need. Um, but yeah, thank you all so much for your time. Thank you so much again, Dr. Wise, and thank you for your thoughtful responses to all these questions.
yeah, absolutely. It was great. I always like doing this, and hope to see all of you sometime in the future.
I have the feeling you might.
All
All
right. Have
right.
a good evening, guys.
Have a good one. Thank you.
Bye, everyone.